Hello, and welcome to this presentation getting started with the LMG600 Transient View. In this presentation, we'll show how to use the transient recording and analysis functions of LMG600 series precision power analyzers. Most power analyzer measurements are so-called steady-state measurements, where voltage, current, etc. stay relatively constant. A transient, on the other hand, is a short-duration event. Transients typically occur during startup, oscillation, etc. It's very important to measure and analyze transients, but detecting and accurately recording transients may be challenging, requiring a high sampling rate and/or sophisticated triggering. It should also be noted that unlike traditional scope measurements, transient measurements are not acquired continuously or cyclically. Rather, these are usually single-shot measurements triggered by a user-defined event. In the remainder of this presentation, we'll explain how to configure, run, and analyze transient measurements on LMG600 series analyzers. Transient measurements on the LMG require the Event Trigger software option. In the case of the LMG671, up to 16 different types of data or tracks can be simultaneously recorded, and up to 16 million measurement samples can be stored. The user defines the recording settings, such as duration, sample rate, and pre-triggering, as well as the trigger or triggers that are used to start the capture. These are usually waveform properties, but may also be external electrical signals. After the transient has been captured, it can be graphically analyzed directly on the LMG, and/or the data can be logged to a file and exported for additional analysis or documentation. Transient measurements are configured from the Graph menu under the Transient tab. Pressing and holding one of the rectangles on the left causes a pop-up dialog to appear, and in this dialog the measurement value or signal, as well as the phase and group, can be selected. A wide variety of values can be graphed, such as voltage, current, power, etc. On the LMG671, this process can be repeated for up to 16 traces. After selecting all the desired measurement values, the next step is going to Transient Control, which is accessed by pressing the button in the bottom right corner of the screen. Transient control settings can be divided into two groups, the first of which specifies how samples are acquired and stored. The record length parameter controls the duration of the recording and is entered in units of seconds. Sample rate sets the rate at which data is recorded, with higher values providing better resolution, but requiring more storage. The LMG may adjust this value slightly upwards when needed. The pre-trigger enables capture of signals for a period of time before the trigger event. One thing to note is that record length and sample rate are interdependent, in the sense that if the user-entered parameters are incompatible, for example, too long of a record length for a given sample rate, then the user is prompted to select which parameter will be adapted. The next group of settings under Transient Control are related to the triggering system. The Trigger System Start-Stop button is used to place the system into searching mode, that is, into a state where the system is waiting for a trigger event to occur. Pressing on the left side of this key starts the search, and pressing on the right side stops or aborts this search. The system can also be manually triggered by pressing the manual trigger key. The system state must, however, be searching for this button to be active. In addition, manual triggering can also be started by pressing the execute key on the front panel. This is configured in the Actions menu, which is described in a separate presentation. By default, the system only triggers a single time on the first trigger event, but auto rearm can be enabled in order to have the system begin a new capture each time the trigger event is seen. Note that the previous trigger capture and sample storage must, however, first be completed before another capture will be started. If trigger rearming is enabled, all of the captures will also be stored in the same log file. We'll discuss logging a bit later in this presentation. The last button is Configure Trigger, and this is where we define the conditions that represent a trigger event. Triggers are configured in terms of per-channel upper and lower bounds on voltage and/or current. These are referred to as Limit A and Limit B. 3 triggers are available, and these can be configured independently. The limits, their values, their conditions, and the active signal are all displayed together in the Trigger View window shown here. In this example, Trigger 1 in red is defined as the current being either greater than 600 milliamps or less than minus 600 milliamps. And Trigger 2 in green is defined as the voltage being greater than 175 volts or less than minus 175 volts. Over the next few slides, we'll go into more detail on how to configure triggers and their parameters. After selecting a trigger to configure, the first step is choosing which signal will be used for triggering. This can be either voltage or current for a given phase/link. The 2 limits, Limit A and Limit B, are configured by pressing Set Limits and entering the values. These limits can also be set by manually dragging the corresponding horizontal lines in the Trigger View GUI. 2 additional menu items, Arrange and Move, can be used to change the display range or to set limits based on this display range. Once limit values have been entered, the conditions relative to these limits must also be configured. One option is defining the trigger as being a value above a limit or below a limit. The trigger can also be defined as a value lying between these 2 limits, or as a value outside of this range. It's also possible to disable the limits when needed. The final group of configuration settings for trigger can be found under More Trigger Settings, which we'll look at next. Under More Trigger Settings, logical linkage defines whether triggering occurs when all conditions are met simultaneously, that is a logical AND, or when only a single condition is sufficient, a logical OR. The Trigger On parameter has 2 possible values. The first is Trigger Edge, in which the trigger point is the first new occurrence of the trigger condition. For example, for this waveform, we define our trigger as a given level, Limit A, being exceeded. After the trigger search is started, the edge trigger takes place the next time the waveform rises through this value. If, however, we were to select Event Level, then the trigger would take place immediately after the search start, since at the start of the search, the configured value is already above the limit value. And finally, the Event Duration parameter defines how long the condition must persist, uninterrupted, to be considered a trigger event. More Trigger Settings also allows the configuration of an external trigger input or output using the Transient I/O pin on the rear panel DB15 synchronization interface connector. If this pin is used as an input, then a rising edge on this pin will be interpreted as a trigger signal. If the mode is set to output, then a pulse out will be generated on this pin every time that a trigger event occurs. Following a trigger event, measurement data is recorded, fetched, and displayed graphically. The horizontal and vertical scaling of this graph can be done manually or automatically using the Arrange button. Cursors can also be used to obtain precise numeric values, as well as the delta values between 2 points. This is done for both the y-axis or amplitude values, as well as for the x-axis or time values. Note that the LMG also automatically calculates the reciprocal of the time difference. More detailed analysis of samples can be performed using the Sample Vision software running on a PC. Measurement values are logged in .zlr format, but can be easily exported as .csv or .mat files. Recording of transient measurement values to a log file is configured by pressing the Storage Hard key and then going to the Log tab. It's important to keep in mind that the log file must be created and logged values must be defined before starting measurements. The user can specify the destination folder and file name pattern for log files, and an optional plain text comment can also be added to this file. The Configure Values button is used to select which values to log. We'll cover this on the next slide. Once a value has been configured, it will be displayed in the Values area of the screen. The Configure Values menu is where we select which values are to be logged to the file. This is done by selecting Type as Transient and then Transient Scope under Name. Here, one of the 16 transient traces can be selected. These correspond to the 16 possible traces that can be configured under the Transient tab. The Add and Remove buttons are used to insert or delete values, and these values can be reordered as well. The Bounds parameter is used to limit the range of defined samples when needed. When configuration of values is complete, press the Enter hard key to return to the logging menu. The next step is pressing Create and Start. Recall that logs must be created, configured, and started before a transient measurement is triggered. Initially, the log file will show no data because a transient measurement has not yet been triggered. But with each trigger event, a new set of measurement data will be logged to this file. When measurements are complete, pressing the Stop button will end logging and close the file. Please see the presentation Getting Started with the LMG600 Logging for more details on log files and how to use them. Another way of recording transient measurements is using the Snapshot function under the Actions menu. When properly configured, the Snapshot function allows both screenshots and numeric measurement or trace values to be saved by pressing a key or the rotary knob. We won't go into detail on the Snapshot function here, so please see the separate presentation Getting Started with the LMG600 Actions menu to learn more about this function and how to configure it. Let's end with a brief summary. Transients are short-duration, non-steady-state voltage and/or current events, and the capture and analysis of transients is very important in many power applications. The requirements for measuring transients fall into two main categories. First, the duration of the recording and the sampling rate, and second, the trigger used to start the measurement. This trigger may be one or more waveform properties, such as current exceeding a given threshold, but may also be an external electrical signal. Captured transient data can be analyzed directly on the LMG itself in graphical format, but the numeric values can also be saved and/or exported for analysis. This analysis can be done using the Sample Vision PC software application or by exporting the values in either CSV or MATLAB format. This concludes our presentation, Getting Started with the LMG600 Transient View. If you'd like to learn more about transients, power analysis, or power analyzers from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.